Okay, here's another video on some more trig relationships, some more proofs. You're gonna be trying to show that one side equals the other side. Okay, so show that this trig identity here equals that. Okay, so I want to work. I have left side, I have right side. You choose whatever side has the most options to you, and you work with it, and you try to get them left side and right side equal to each other. So I'm going to work with the left side here. Left side is simply, and I want to just rewrite it: cos theta over 1 plus sine theta plus 1 plus sine theta over cos theta. Okay? Now, I have fractions here and adding, so I need a common denominator. My common denominator is going to be these two things multiplied together. So, multiplied together, it's going to look like cos theta 1 plus sine theta. And I want to have the other denominator here as well, cos theta 1 plus sine theta. So that's my common denominator. So I got whatever I do to the bottom, I got to do to the top. So I took this fraction, I multiplied both sides by cos theta, top and bottom. That gave me my common denominator. So when I do that to the top, it's going to give me cos squared theta. Same thing, when I did it, this second fraction, to get the common denominator, I had to multiply by what was missing, which would be the 1 plus sine theta. So when I do that, I have a 1 plus sine theta multiplied by another 1 plus sine theta, which would be 1 plus sine theta squared. Now I can add the two together. So in doing so, you have cos squared theta, because I have a common denominator, I can add them together, plus, and I'm going to expand this at the same time using my a squared, 2ab, b squared. It'll give me 1 plus 2 sine theta plus sine squared theta all over cos theta 1 plus sine theta. Okay, so working here, I have a sine squared theta and a cos squared theta adding, so I know that's going to give me another 1 because that's the Pythagorean identity. So I want to have another 1 plus 2 sine theta all over cos theta 1 plus sine theta. Always important to keep in mind what you want to get to. What's your end goal? 2 over cos theta is my end goal. That's what I want to get. So I'm going to want to have the cos theta on the bottom eventually. So let's just keep on doing some algebra. What do you see here? Well, 1 plus 1 is 2. So I'm going to have 2 over your equal signs. 2 plus 2 sine theta all over cos theta 1 plus sine theta. Common factor of 2 on the top. That's the only other thing I'm seeing right now. So 2. That'll give me 1 plus sine theta. Oh, that works out because that would give me cos theta 1 plus sine theta. The 1 plus sine thetas can cancel, and you're simply left with just 2 over cos theta, which is what your right side was. So therefore, left side equaled right side. Okay? There we go. That's what I was looking for. Again, another show that. Okay? So let's see. I have my left side, my right side, and as coincidence, my left side is again what gives me the most things to work with, and most possibilities. So that's what I'm going to do. Okay, so I have some double angle formulas to work with on this. And if you haven't watched a double angle video, you might want to do so before proceeding to this, because that's what you're going to be substituting in. So the sine double angle is 2 sine x cos x. I had to keep with the x because that's what was given, minus sine x. The double angle cos formula, you have 3 options, but you might as well choose the one that has the most applicable one to it, the best case scenario for you. You know your right side is tan x, which is secretly sine x over cos x. And that's probably what I'm going to want to get to. So, well, cos on the bottom, so I'll use the cos double angle formula that has only cos in it. And that is exchanging it. It is going to be 2 cos squared x minus 1 minus cos x plus 1. Okay, so I just did my double angle formula exchanging right there. So I have 2 sine x cos x minus sine x on top, all over. My minus 1 and plus 1 will cancel out, so I have 2 cos squared x minus cos x on the bottom. I can do a little bit of common factoring. I can take out a sine on the top, so sine x, I'm going to have 2 cos x minus 1. I'm going to take out a cos x, and common factor out a cos x on the bottom, and that'll leave me a 2 cos x, hey, minus 1. Wonderful. These two are the exact same, they can cancel out, and I'm left with sine x over cos x, which is what I was hoping for, because that's equal to tan x. And now my left side is equal to my right side, because I wanted to prove that it was equal to tan x. Okay, so this is another lesson on some more trig relationships and trig identities. Thank you very much.